All right, welcome everyone to our Pollen Trackers Kickoff webinar. My name is Erin Postumus. I'm the outreach coordinator with the USA National Phenology Network based at the University of Arizona. And I am fortunate to be joined today by a couple of the researchers who are behind this campaign. We have Ari Manigan, who is the health scientist with the Center for Disease Control and Prevention in their Climate and Health program. And then Dan Katz, who's a senior research associate in the School of Integrative Plant Science at Cornell University. And so we're going to be getting started here with our training webinar. But before we do that, I just wanted to give you a brief orientation to our Zoom interface here. So you'll see that there is a chat that you are welcome to use if you want to talk to us, talk to any of the researchers that are on here. We also have a Q&A feature. So if you do have a question that you'd like to ask, please put it in the Q&A. You should see that at the bottom of your screen. And that will help us to more easily answer those as we go along. We will have time for a Q&A at the end, but I just wanted to make sure that you knew about that in case you want to put in questions as we go along, as you think of them. We are recording this webinar. We'll be sending out a follow-up email later today that will include the recording as well as any other resources that we share during the webinar today. So with that, I'm going to share my screen if I can find the right one. All right. All right, so what we're going to be doing today is we'll have Ari and Dan share a little bit of background on why we are launching this campaign and the importance of the data that we hope you all will collect. Then I'll give a brief overview of what the USA-NPN is all about in our Nature's Notebook program. And then we'll get into the details about how you can get started as a pollen tracker. And then we'll go over some of the training resources that we have available and make sure we have some time for a Q&A at the end. But in the meantime, I welcome you. If you'd like to let us know where you're calling in from, I know we have people from all across the country, so feel free to put that in the chat. And then also, I'm curious, I know that there's some cold weather in some parts of the country right now, but are you seeing any signs of spring where you live? Spring's coming up next week, so we'd love to hear about anything that you're seeing around you. So with that, I'm going to turn it over to Ari first.
All right, well, good morning, everyone on the West Coast, and good afternoon here on the East Coast. Again, I'm Ari Manigan. I'm a health scientist in the CDC's Climate and Health program. And for the Pollen Trackers Kickoff Training webinar, I will be talking about the effects of pollen and health. Next slide, please. So today I will be talking about the health effects related to pollen exposure, the public health burden of pollen-related illness, the climate impacts on pollen and pollen trends, and the importance of pollen forecasting. Next slide, please. So here are some examples of how allergenic pollen can affect health. So not all pollen is allergenic or causes allergy-related symptoms, but pollen from oak or juniper, for example, and weed pollen from ragweed can cause allergies. So among some people, exposure to pollen can lead to asthma attacks, a stuffy nose, or red or itchy eyes. Next slide, please. So outdoor allergenic pollen and mold are the primary cause for allergic rhinitis, or commonly known as hay fever. So as pollen counts increase, the risk for allergy-related illnesses also increase. So a study by Darrow and colleagues in the Atlanta area found a 10 to 15% increase in risk for asthma-related ER visits during high pollen count days. And another study found that allergy medication sales also increased after peaks in oak, maple, and birch pollen. Next slide. So pollen has significant public health and economic impacts. Allergic rhinitis, again known as hay fever, affects 30 to 60 million people in the United States, with a disproportionate effect on children. Additionally, seasonal allergies can exacerbate pre-existing respiratory health conditions such as asthma. So asthma, as we know, disproportionately affects Black, Hispanic, and American Indian and Alaska Native people, as these groups have the highest have the highest asthma rates, deaths, and hospitalizations. And also in a single year, Americans spend $11 billion on medical costs associated with seasonal allergies, which include indirect costs related to missed school days and work. Next slide, please. So one of the impacts of a changing climate is an increase in outdoor aeroallergens and pollen. So previous research by Dr. Louis Siska, formerly from the USDA, found that as CO2 concentrations and temperatures increased, the production of allergenic pollen also increased in ragweed. So even under the most conservative emission scenarios in the recent National Climate Assessment or the IPCC report, climate projections show both an increase in temperature and CO2. So the length of pollen seasons are also increasing as shown in this figure. This figure shows how the length of ragweed pollen seasons changed at 11 locations in the United States and Canada between 1995 to 2015. These red circles represent a longer pollen season, and the blue circles represent a shorter pollen season, and the larger circles indicate larger changes. Next slide. These changes in pollen seasons are happening throughout the world. So in a literature review that included studies throughout the globe, warming temperatures are associated with pollen seasons that are starting earlier, lasting longer, and are more intense with higher pollen counts. Next slide, please. So I guess a couple years ago in 2021, we conducted an analysis to investigate these localized trends in pollen concentrations and pollen season timing and how seasonal climate variations affect pollen. So working with Dr. Stanley Feynman, who's an allergist with the Atlanta Asthma and Allergy Clinic, we were able to analyze their pollen data set that they have been compiling since 1992. So we found that the average daily pollen count during the pollen season has increased over the years for both the spring tree pollen season and the fall weed pollen season. And more specifically, we're seeing increases in oak, juniper, mulberry, and willow, all of them increases. For several types of pollen, seasons were occurring earlier and lengthening. So here we see those statistically significant pollen count trends over time, colored in the red linear trend line. All of those are statistically significant and increasing. Next slide, please. So as expected, we also found that warmer spring temperatures were associated with an early pollen release, as shown in this graph. We also found that increased precipitation from the preceding fall was associated with increased pollen concentrations in the spring months for a few types of pollen. And variations in seasonal climate do have an effect on pollen counts and pollen season timing. Next slide, please. So what are the tools we have to address this growing concern? So we conducted a literature scan of public health interventions related to pollen and found 5 main ways seasonal allergies can be targeted. First are these environmental interventions. So this means adjusting the environment to reduce pollen in the air. This may include planting trees and plants that do not put out as much pollen in the air, such as female trees and plants pollinated via insects in our landscapes. Or this may also include performing maintenance of areas where pollen-producing weeds, such as ragweed, has flourished. So second is raise communication and awareness about the pollen season, so people with allergies can better prepare for and respond to these seasonal shifts and other aeroallergens. So these communication campaigns may include an air quality alert system or an email update from your allergist or primary care provider. These communication awareness campaigns could warn allergy sufferers so they could plan their activities to reduce their pollen exposure. So for example, staying inside when possible, when pollen counts are very high, which may be especially important to those who have respiratory illnesses like asthma. Third is immunotherapies and medication. Immunotherapies are shots given to expose them to small doses of what they are allergic to, so their body's reaction is less. And then there are allergy medications such as antihistamines, which I'm sure, well, a lot of folks in the South are very familiar with. These can reduce the body's allergic response and improving symptoms such as itchy and watery eyes. And fourth is improving indoor air filtration, so outdoor pollens do not come inside. And finally, fifth is an enhanced health and pollen monitoring. So we know when pollen is at a level that is dangerous to health, so we can better target our activities and communications. And next slide. So timely and accurate pollen forecasts could help prevent pollen exposure, especially for those most at risk to severe health outcomes. Enhanced pollen monitoring could provide more effective communication campaigns and awareness campaigns. For example, forecasting when people should try to spend less time outdoors when pollen levels are high. And also supports evidence-based decision-making for the timing of health interventions. For example, when to take medications or start immunotherapy. And that is the end of my presentation, and I think we'll be taking questions at the end of the next presentation. Thank you very much.
All right. So I'm going to pick things up here and tell you all a little bit about what information we have about pollen right now. Now, the main source of information about airborne pollen concentrations in the United States comes from the National Allergy Bureau Pollen Monitoring Network. And this is a network of approximately 80 pollen monitoring stations across the United States. In the photo on the right, you can see a Burkhardt sampler, which is one of the instruments that are used to collect pollen concentrations. And so we owe a great deal to this network. The folks who work at these stations go out there often 4, 5, sometimes even 7 days a week and collect pollen samples, and then they analyze them and then report them to the news media. So this is really crucial work, but there are some big limitations too. One of the issues is that for many Americans, we don't have a pollen monitoring station near us. For example, where I am based in upstate New York, the nearest pollen monitoring station is 80 miles away. And there are big chunks of the US where there isn't a station close by. This is a problem because airborne pollen concentrations can vary by orders of magnitude over distances as small as half a mile. And so this is a little bit of an issue. Furthermore, the data collected by these stations, they collect the data for a 24-hour period and then they analyze it. So when we get these counts of pollen concentrations, that's yesterday's data, usually from a good distance away. Next slide, please. Now, an alternative approach to having these specific measurements from pollen monitoring stations is to create models of airborne pollen. And so what we can do is combine estimates of how much pollen a particular kind of tree or other plant produces and maps of where those plants are. We can then combine that with the timing of flowering or of pollen cones opening up to create estimates of pollen release. And here you can see an example of a pollen release model that includes the timing of release, in this case for oak pollen in Detroit, Michigan. And so with this kind of information, we can combine it with data about how the wind is blowing to estimate both how much pollen is in the air, and ultimately we can use this information to both inform people what's happening right where they are right now and even into the future. Next slide, please. Now, one of the things that's kept scientists and other people who are interested in allergies from actually making these models is that we need a ton of information about what plants are flowering where, because each type of plant has its own relationship to things like temperature and day length, and, which determine the timing of flowering. And without knowing when something is flowering, we can't do a good job of making those models. The figure in front of you now shows observations that were contributed to the National Phenology Network for oak trees. The dots, the gray dots and the circles indicate the number of flowering records. So you can see that we have a lot of records already. Next slide, please. And with that, we can begin to do some interesting analyses that begin to help us understand these relationships. The panel on the left here is just for oak trees. It looks like the x-axis got cut off, but that is the mean annual temperature in degrees Celsius. And on the y-axis of that first plot is the date when these oak trees were observed flowering. And so you can see there's this relationship where in colder areas it flowers, oak trees flower later, and in warmer areas they flower earlier. When we compared that relationship with peak pollen concentrations from the National Allergy Bureau network, which is shown on the right graph, we see that it works quite well to predict airborne pollen concentrations. And so this recent publication provides a good proof of concept that with enough data, enough observations of flowering, we can begin to predict airborne pollen concentrations. Next slide, please. So that's why this matters, and that's why we are expanding pollen trackers, to a national level. And so your observations are going to help by creating the only national scale data set that we have on the timing of flowering or on cone opening. And with that, we're going to be able to make better models of airborne pollen and get all of the benefits that Ari was talking about. That will help us to reduce the impact of pollen on people's lives. So that is why we are asking you for your help and participation in the Pollen Trackers campaign. And I think that is about it for my slides.
Excellent. Thank you both so much for that really amazing overview of why this is so important and how the data are really going to plug in and really help with this forecasting. So thank you. We did have one question come in, but I think we'll save questions for the end so we can get a few more questions before we open it up for the Q&A. So I'm going to move right along then into, oh, this is Dan's contact info too here, which we can also share in the chat. So I'm going to move on to talking about how you can be part of this campaign and participate as a pollen tracker. So I just wanted to get a sense of from the folks on the call today, whether or how you keep track of phenology where you are. And so I am launching a poll here. Feel free, I think you can check all that apply here, but do you keep a nature journal? Do you take photographs? Do you actually contribute to an online platform? Or maybe you're even already a Nature's Notebook observer. So just to get a sense of who we have on the call here, we'll give it a little bit longer. We already got people reporting in. We've got quite a few Nature's Notebook observers on here, which is great. And I did see some of you in the participant list too. All right, give it a couple more seconds. All right, so we have the majority of people said, I take photographs of the plants and animals that I see. That's great. That's a great way to document the things that you're seeing. And then a lot of people keep a nature journal. And then we have 8 Nature's Notebook observers on the webinar today, which is excellent. And then a few of you said, I pay attention, but I do not yet record what I see. So that's great. Okay. Oops. So Phenology has many different applications, and I always like to share this slide because it just shows the breadth of the different things that all connect with Phenology. So if you haven't heard the word Phenology before, you probably have if you've been active with us for a while, but The definition that we use as phenology is simply the timing of life cycle events of plants and animals and their relationship to environmental variables, things like temperature and precipitation. But really, maybe the most obvious thing you might think about when you think about phenology is aspects of ecology. So things like, when plants are blooming and whether there might be pollinators coming in that are interacting with those plants, and whether those might be becoming mismatched with each other. But there's also many, many other applications as well for things like agriculture, wildfire season, invasive species control, and of course, public health aspects as well. So we were established as the USA National Phenology Network back in 2007. And really the purpose was to collect, store, and share phenology data and information. At the time, there wasn't really a standardized way to collect phenology data in the country. And so we were created as a way to do that. And really, we try to do a lot more than just kind of hosting and storing and sharing the data. We do try to make sure that the data we make available are useful for scientists and their research, and then also people in natural resource management and things like public health, where we can actually give them information in the format that's useful so that people can make decisions off the ground. So the primary way that we collect data is through our Nature's Notebook program. This map here shows the many, many different stations across the country that have submitted data to our program. And then the circles on there show sites that have a lot of data that have been submitted. And so you'll see some of those circles, especially in the more rural parts of the country, are sites belonging to the National Ecological Observatory Network. They use our plant protocols. And then we also have many sites in more of these urban areas, especially along the coast. And so if you see a place where you live that doesn't have a lot of data, we're really interested in having you sign up and contribute data to help us kind of fill in those gaps. So in addition to just running this Nature's Notebook platform, we also try to drive the focus of data collection on particular species. And these are often campaigns that are initiated by researchers that come to us and ask us to collect data, and sometimes natural resource managers as well, partners like the U.S. Fish and Wildlife Service that need data on a particular species. And so they ask us to call upon our many observers across the country to help them collect data. And so this is just a sample of some of our campaigns. We have 10 campaigns that we're running this year, which you can find on our website here. And I see Samantha Brewer from the NPN office is also on the webinar today, so maybe she can help put some of the links in the chat so you can go directly there. So for pollen trackers, just to kind of give you an overview of the steps to getting started, the first thing you'll do is you'll create a Nature's Notebook account. And then you'll set up a personal site, which is the place you'll collect your data. You'll add at least one of our pollen tracker species. You'll record data on your plants. And then we also hope you'll sign up for our campaign emails so you can get results of what we're finding with this campaign. So just kind of walking through these steps, we highly recommend downloading the Nature's Notebook app. And this is the little icon for the app if you want to look out for that on the app stores. And when you create an account, all you really need is your username, a password, an email address. And you might see on the app screen, there's a question about partner group. Feel free to skip that. You don't have to worry about that. When you participate in a campaign, you don't need to sign up for a group. So you can just set up your account. And then you'll want to add a site. So this is what the adding a site screen looks like in the app. And then you can use this map here. You can either type in an address or you can zoom into the map and move that pin around. And for this campaign, we're really interested in knowing the precise location of where your plant is located. That's really going to help us out with the data analysis side of this. So if you can kind of zoom in and put the point right on the tree or the plant that you're planning on monitoring, that will really be helpful for us. And you'll be able to zoom in a lot more than this screen cap here. This is just what you start with, and then you can zoom in on the map and find your location. So we have a lot of species that are part of this campaign. And because there are so many, there are actually over 150 species that we have. This is our largest campaign in terms of the number of species. I've just listed the genera here on this slide. And so you can see there's a breadth of different species. We have all sorts of things from maples to ragweed, to ash trees and junipers. And so I realize that this is a lot to sort through. And so to help it make it a little bit easier, I recommend going to our Nature's Notebook website and then go to the plants and animals page. And you'll see a screen where you can filter. And so you can actually select your state, which you can see on this screen here, and then open up the advanced tab. And we've added the Pollen Trackers campaign as a plant group. And that will just filter down and help you find what species are available in your state. And so for me, I just put in Arizona, and I see there's lots of options here. There's 4 pages of species available for me. So that would probably be the easiest way to find out what's available for your location. And then you're welcome to also add other details. This unfortunately can't be done on the app, but if you're already on the website, you can use the account information you set up on the app to log in, and then go to this add or edit plants. And then we always like to know a little bit more about the plants you're tracking. So you can fill in things like how shaded your plant is, whether it gets any supplemental water. If you know the planting date, that kind of helps us get a sense of the age of the plant. And then you can put whatever else you like in the comments field here. And so that can kind of help us get a little bit more detail. If you're already a Nature's Notebook observers, you're welcome to add a Pollen Trackers plant to your existing site. Or maybe you already are tracking one of our Pollen Trackers species. I know that there's quite a bit of overlap between some of these species and our Quercus Quest campaign, as well as our Green Wave campaign. So if you're already tracking one, that's great. You don't need to do anything, just keep collecting your data. And then also make sure you sign up for those emails so you get the updates for this specific campaign. But if you like to, you can also set it up as a new site if you just kind of want to keep it separate, or especially if it's in a different area. Maybe you're going to find a maple tree down the road or at a park or something like that. You can create a second or an additional site for your Pollen Trackers plant. So when you get to recording data, this is what a data sheet will look like for some of our species. This one's for paper birch. And what we are really interested in for this campaign is the flowering phenophases. So you'll see we have 3 of them. We have flowers or flower buds, open flowers, and pollen release. And on the right here, you can see a table where we've included the question that we're asking, as well as what we call our phenophase definition. And a phenophase is just a life cycle stage. And we have a really explicit definition about what we're asking about. And we'll even, as you'll see in a bit, we have even more detail when it gets down to the specific species, but you'll see we're really trying to give you all the information you need to know. You don't have to have a background in botany or anything like that. We try to give you all the information you need to answer these questions. And this table is located on our Pollen Trackers landing page as well. So just to kind of give you a sense of how the data collection works. So this is what kind of how it would fall out in a particular year. So at the beginning of the year, once you start seeing your flower buds on your plant, you start reporting a yes to flowers or flower buds. And then when you report on your plant, you're actually going back to the same individual tree over time. And we'd like to have you report on if you don't see open flowers, actually answer this no here on the data sheet. So we want to make sure we get both the presence information as well as the absence information. So if you went out and you saw just a bunch of flower buds on your plant, you would say yes for flowers or flower buds, and then you would say no for open flowers and no for pollen release. And then as the flowers open, you actually will continue to say yes for flowers or flower buds, and then also say yes for open flowers. But if you're not seeing pollen release, then you would say no for that. And then once you see pollen release, you're going to be saying yes for all 3 of these phenophases. So just keep that in mind. So just to kind of walk through what this would look like. So for this first photo here, again, of paper birch, we would say yes for flowers or flower buds. These are very tightly closed catkins or flowers on this plant here, but they're not quite open yet. So we would say a no for open and a no for pollen release. For this middle photo, we would see that the flowers have now opened and they're kind of dangling. They've opened like an accordion. So we would say yes for both flowers or flower buds and open flowers. And for pollen release, it's hard to tell from the photo here. Maybe if you're interacting with this plant, you might be able to see or feel the pollen grains, but I would say not sure just based on this photo. And then with this final one here, we have our flowers or flower buds, we have open flowers, and then we also have pollen release, as you can see on the photo. So in terms of how you can collect, I mentioned we highly recommend our app. It makes it easy to just do a one step of submitting your data right from the field. The app does work offline. So if you're in an area without service, the data are stored locally on your phone and then will be uploaded when you get back into the service or into a Wi-Fi connection. Or if you like paper data sheets, we also have those available. You can download them from the website from your observation deck, which is where when you log in, that's where you can see all of your sites and your plants. And then you can enter them online in the online interface that matches the data sheet. So just a note about observation frequency. We would love any data that you can record. So don't worry if you can only go once a month, that's okay. But ideally, we're looking for weekly observations or even more frequently, especially around the time when you're seeing those transitions. So the change between when you see the flower buds to when they start to open, as often as you can go, the better the data, because what we're looking for is that precision around your estimate of when things opened. So if you think about if you're going, say, weekly, and you said no last week, and then you said yes this week, then we know that the first yes really happened, or the first open flowers happened sometime during that period. But if you're going every couple of days, every 3 days, then that period of uncertainty is only 3 days long. So that is more useful when we're doing the data analysis, if you can go more frequently. But prior to that, you could go, up until you see things start to get close to opening. You could go less frequently, and then once the flowers open, you could also go less frequently at that point. But really, these transition periods is where we're really interested in. We also have a secondary question if you do say yes to one of these phenophases, which is what we call intensity. And so this is where we're asking not just do you see any flower buds, but how many do you see? And keep in mind, this is an estimation, and what we're asking you to do is try to put your estimate into one of these bins. So you'll see we have, these are exponentially increasing bins. So we have less than 3 flowers, 3 to 10, 11 to 100, on up to more than 10,000. And so some people feel like this is a little bit overwhelming. I think it's totally fine to skip these. Everything is optional, so you can just answer the yes or no questions as you first get started. Or once you feel comfortable, you can start adding on these intensity questions. And this can also be something that can be easier to do after you've observed your plant for a year. So once you've kind of gotten to know what it looks like at the peak open flowers or the peak flowers or flower buds, it can be a lot easier to answer those questions. I think it can also be helpful to kind of rule out different bins. So if you know that there's just a ton of flowers on your tree, you can probably rule out these smaller bins and then try to pinpoint which of these two it is. So that can be kind of a helpful trick as well. And just another thing to keep in mind, what we're really interested in with these intensity questions is the peak. So don't worry so much about getting exactly the right bin. What we're really trying to get at is when was the most that you saw? So when was the highest percentage of open flowers? So if you started a bin that's not quite right, as long as you can capture that, the most open flowers on your plant, that's really what we're interested in here. And if you do track a pollen tracker species for 6 different weeks this year, you will earn a virtual badge, which you can see on your observation deck. All right, so I wanted to run through some photos, and not being able to meet in person and do a training, we kind of have to be creative, and we try to use photographs to simulate what it might be like to make observations in the field. But I put a couple photos on here of Ash's juniper from Texas. And I wanted to just kind of do a little poll here, maybe just in the chat for this one, but of these 2 photos, which one, the left or the right, would you say are open cones here on this juniper plant? I don't know if anyone wants to put in the chat, do you think it's the left or the right? I'm getting some rights. Yes, so yeah, it seems pretty obvious when you can see them this close, but you can hopefully see the difference here between these cones on the left here are very tightly closed. There's no gaps really in between the scales. So the right one is much more obviously open. So that's the difference that we're looking for this particular species. So nice job, everybody. And now let's move on to another one. And for this one, I actually have another poll that I'd like to launch, which I will bring up here. And this is a cottonwood tree. And so I'm going to launch this, and you'll see that I've actually included here the 3 questions that we have: flowers or flower buds, open flowers, and pollen release. And I've included as much as I could fit of the phenophase definition. These are actually really long definitions, so I haven't included every word, but hopefully you have what you need here to kind of answer the questions here based on the photograph. So try your best. There is a question mark on there, so we always welcome you to put the question mark as it is on the data sheet if you're not sure about what you're seeing. So feel free to answer the questions and then submit them, and I'll give a couple more, another minute here for people to, okay, now they're rolling in. So I'll give it another few seconds for people to submit. And also I will say that it can be a lot to read through the whole definition and kind of digest it at first. But once you've done this a few times, you get to know exactly what you're looking for. And it really becomes pretty quick to answer the questions. And especially when you're going back to the same plant over time, even just every week, you really get to know your plant, and it's pretty easy to just see kind of what's changed since last week and then put in your answers for the data sheet. All right, we've got over half have participated so far. I'll give it just another few seconds for people to answer. And if you can't see the image, you should be able to move the poll around on your screen too. You need to be able to see it. Okay, so I'm going to close this one and let's share the results. Okay, so for the first question, we had everyone said, yes, I see flowers or flower buds. And that's great. So it does, this is a species specific definition. So it says for Populus fremontii, both the male and female inflorescence is a catkin, which is initially compact, but eventually unfolds to become longer and hang loosely from the branch. So you can see, even without having seen this plant before, you can probably tell that this is pretty tightly compact. And you can kind of see that these are the scales here that were around the flower bud, and they're just emerging. So this is a pretty new flower. So it's great that people said yes for this. As for open flowers, this says the flowers are open when the reproductive parts are visible. And it says for this plant in particular, the flowers will open once the initially compact catkin has unfolded and is hanging loosely. And so we had, most people said no. We had a couple people that said yes and a couple question marks. I would say this is a no for open flowers. And again, it's easier once you've seen your plant and gotten to know it a bit. But as you watch this plant, you'll see it expand and the catkin will really unfold and be dangling from the tree. So it'll be pretty obvious once you've seen that to be able to tell the difference between a bud that's not open yet and then an open flower. And then for pollen release, again, hard to know from a photograph, but based on how tightly closed these buds are, it's pretty safe to say no for pollen release for this. And also another note on pollen release, we did decide to include it even though it can be really tricky, especially for these large trees where sometimes you can't even touch the flowers because they're up so high. You can often use binoculars to get a sense of whether the flowers are open if you're dealing with a really tall tree. But if you're not able to really assess whether there's pollen on your flowers, it's perfectly fine to skip that question or put a question mark. We don't want you to try to guess at what's happening way up there if you don't have a good idea of what you're seeing. All right, well, great job, everyone. We have one more, and this is a northern red oak. So I'll launch this last poll here. And it's fairly similar in terms of the definitions, although the species specific part is different. Wow, we've got people answering right away. So much faster now that you have some idea about what you're looking at here with the definition. But I'll give it another minute for people to answer. And also feel free to keep putting your questions in the Q&A, and we will get to those at the end. All right. Wow, you guys were fast this time. Okay. So we have, let's see, everyone said yes for flowers or flower buds. Great job. Everyone said yes for open flowers. Also great. As you can see, it says that this is also a catkin that expands and hangs loosely. And so now that you've seen this one, it's probably a lot easier to know from the last photo that that one is very tightly closed and looks quite different. In terms of pollen release, so it's kind of hard to see, but there are some little pollen grains if you look closely on this finger here. So if you were there, it might be easier to kind of see it as the pollen falls off of the flowers, but we would say yes for this one for pollen release. So this one gets all 3 for yes. So nice job, everybody. Okay, so we definitely want to make sure that everyone gets signed up on our Pollen Trackers list. So hopefully if you have your phone with you, you can use the QR code on the screen here to get signed up on the email list. It's also on our Pollen Trackers landing page on the right-hand side of that page. But the campaign emails are really important for staying in touch with us. We'll be sharing tips on how to observe. We'll be sharing resources on things like species ID. We'll also share a lot of results. So we'll be emailing you every 1 to 2 months with updates about what other people are reporting. This is a really exciting campaign because it has so many species. So I'm not quite sure yet how we're going to summarize everything, but we'll probably be doing a lot of family level or genus level summaries of the data. But definitely sign up for those so you don't miss out on hearing about results from the campaign. And we'll also share eventually when the data start being used by our researchers, what they're finding as well. I also wanted to mention we do have lots of training resources available. So we have what you see here on the left are phenophase photo, or sorry, this is not a phenophase photo guide, but we have phenophase photo guides, which have these definitions. This is from our data sheet, but we'll have some of our species have photos along with these definitions. So definitely recommend checking out those. We also have a botany primer guide, which has really everything you would ever want to know about botany to use Nature's Notebook. Although it's not required, you can definitely use Nature's Notebook with just the definitions that we provide. But if you want extra information, this is a great photo-based resource. We also have an observer certification course, and I highly recommend that you take this course. It's located on your observation deck. So when you log into your account, there's 5 different modules. The first one is just kind of generally, how do you get started, set up a site, add a plant, edit data if you need to. And then it goes all the way on through getting to know the phenophases. So really getting into understanding open flowers. And then it also has some tips on estimating intensity. So for these really big trees that you might be looking at, how can you try to estimate those numbers of flower buds? So I definitely recommend checking that out. And then you can also explore the data. We'll be giving you data summaries in the emails, but you can also go onto our visualization tool yourself and check out what's on there. You can look up data on species you're interested in. You can look at your own state or a smaller location. You can look at the whole country. And we have lots of different types of visualizations. We have kind of a tutorial with the seasonal stories that helps you get to know what you're looking at, and then you can modify them to look at species you're interested in. We also always like to emphasize that the data that are submitted to Nature's Notebook are very frequently used by researchers and natural resource managers. We keep a track of all of the publications that have used Nature's Notebook data, and we have over 120 so far. We also do summaries of these papers. So this is something we send out in our bi-monthly newsletter. So I'll have we can put a link for that as well. But we do try to put the journal articles in more of a plain language summary, so it's a little bit easier to digest, and we communicate about the significance of the study and why you should care about it. So you can check out those summaries as well. Also wanted to mention we have local phenology programs. So while you can participate as an individual, what we call a backyard observer, you can also participate with a group of people. So you can definitely check out the resources we have for local phenology programs. Samantha runs an online certification course for local phenology leaders. We'll be running another one of those this fall. And then you can also do a self-paced option this year. We have many, many resources. We have a monthly call that's actually happening this Friday for local phenology leaders, and a forum and a newsletter. So lots of different things. So feel free to reach out if you have questions about that. And lastly, we are celebrating spring next week with Phenology Week. This is also our 15-year anniversary for NPN and Nature's Notebook. So definitely recommend joining us. We have a full suite of fun activities planned. So we have a kickoff webinar on Monday where we'll kind of go over the history of NPN and Nature's Notebook and share with you some resources. We'll have a bunch of NPN staff there you can meet. Then on Tuesday, we have a researcher Q&A. We're inviting a couple of the researchers that have published in the last year using Nature's Notebook data will be coming to talk with us and answer your questions. Then we'll have a release of a video from our director coming out on Wednesday. And then Friday, we're going to have an award ceremony / gratitude party where we'll highlight some major accomplishments of some of our observers and local phenology programs. So you can check out the full list. You can also sign up for daily emails next week where you can get all the details about that. Okay, so just to recap, the steps are you'll want to create a Nature's Notebook account if you don't yet have one. You'll want to add a site and at least one plant, although you're welcome to do more than one if you like. Definitely take advantage of the training materials. You can take the observer certification course. And then make your observations at least once a week if you can, especially during those transition times when you're seeing things changing. And then feel free to reach out. Happy to answer any questions as things come up. If you have questions about a particular plant or how to set up your site, anything like that, we are definitely here to help. And I put the sign up again for the Pollen Trackers messages. So let's take a look at the questions we have and what is in the chat.
Erin, so we did get a message in the chat earlier asking how we ensure that people are recording the correct species of plants.
Yes, so we do kind of rely on you to make sure that you're recording the correct species. There are lots of resources available online to help you, and then also lots of apps as well. So if you're not sure about the species you have, you can try to look for Cooperative Extension is a great resource that is in every state. Usually there's an office near you and you can actually usually submit pictures of a plant and they can help you figure out what it is. You can also use resources like iNaturalist. They will have researcher verified observations or verifications of what you're seeing. And then also I found Google Lens is a pretty good resource as well. It's if you have the Google app on your phone, you basically just open the app and there's a little like a camera icon. If you click that, it'll take a picture for you and then it'll just like do basically an image search. And that is, I found pretty reliable for trying to figure out what plants are. There's also things like Leaf Snap, which is another app where, especially for our more common deciduous trees in the east, if you take a picture of the leaf, it can tell you or try to help you figure out what it is. And if you're really stumped, you can email us and we'll try to help you as well.
And then we also had a question about what about flowering plants other than trees?
Yeah, so we do have some shrubs as well as ragweed on our list. So it's not just trees. You can check out that full list. And I did see there was a comment about the pines not being in there. We kind of made a late breaking decision on including pines. So we're getting those added to the species search page. So they will be in there soon. But yes, we will have pines on the list as well. Other questions? Any questions for our researchers here? I'm sure that you were inspired and interested by their presentations. There's probably some burning questions out there. Or anything else that Ari, you or Dan want to add?
Well, no, I'm just excited to see all these observations, and I think we're going to try to do it in my family as well, try to get the kids out there and try to figure it out. So it should be pretty interesting and fun. And thank you for participating.
Yeah. And I do also want to give a shout out to all of the folks who started off with Pollen Trackers when it was just based in Texas working on ash juniper. I see some familiar names in the chat and just want to thank you all for coming out and for thinking about working with more than just ash juniper. Those measurements have been really useful and have valued your participation so far, and excited to have you with us going forward.
Thanks, Dan. Yes, that was actually the reason, one of the reasons we started this campaign was the Pollen Trackers Texas campaign was so successful at collecting data. We had such a great turnout for that we were kind of inspired that we could do this nationally. So we really appreciate all of your efforts. And I did also want to mention that we have we had at least one other of our researcher team, and maybe I'll just quickly share my screen to show you the other members of our research team that weren't able to be here today. But we do have a lot of people that are involved in this campaign that are really excited about the data that you all be collecting. So you can see a number of different affiliations here, different universities, and even an allergist that we have that are part of our researcher team. So just wanted to give a shout out to all of them too. So we will be sending out a follow-up email with this recording. We'll include all the links that we shared in the presentation today, so you have all of those, as well as the link to sign up for the email. So we want to make sure we get everyone on the campaign list. Just checking. We had another question. Do you use pollen sense devices? I'm not sure what that is.
I'd be happy to take that question.
Thank you.
Yeah, Pollen Sense. So those they are a fairly new company that provides automated pollen monitoring systems. They have so it's a cool set of technology. One of the so it essentially acts like a mini pollen monitoring station with some caveats, but it still has those same limitations that it doesn't really tell us about the plants themselves. And so the observations of pollen that are collected by these pollen monitoring devices, Pollen Sense, the National Allergy Bureau stations, they tell us what's in the air, but we don't know where that pollen grain came from. We don't know which plant it originated from. And so that's why the observations direct at the source are so useful, because we know that it's that plant which is releasing the pollen, which makes things a lot easier when we're creating these biologically based models of airborne pollen concentrations that can extend beyond that one point of measurement. Thank you for the question.
Thanks, Dan. All right, any last questions? All right, if there aren't any other questions, we really appreciate everyone being here today. And I'm sure lots of other people will be watching the recording later. We do have quite a few people that are already signed up on our Pollen Trackers list. I think we're up to about 150. So it's really exciting that we have all the interest, and we'll keep promoting the campaign. And we just really appreciate all of you being interested in learning more. And we'll be in touch over our campaign emails with you about the results. So thank you so much.
All right, thank you. Thank you for the opportunity.
Yes, and thank you so
Aaron,
much
for hosting.
Oh, I was going to say thank you, Art and Dan, again, for sharing all of your insights about how the data are going to be used. Really appreciate your expertise. So thank you.
All right, thank you.